Oh, hey, Liam, the show started.
Oh. Sorry about that. It's finals week for us here in Oswego, and, well, the WeatherWise team here is studying hard, as you can see.
Yes, we are, but don't worry, we have another great show planned for our Season 1 finale.
Christina will be right back after this quick intro.
Good evening, and thank you for joining us for another episode of WeatherWise. I'm meteorologist Christine Gregory.
And I'm meteorologist Liam Healy.
We have another great show planned for you tonight, and I understand, Liam, this is our last show of the semester, isn't it?
Yes, it is, Christine. It's been a great semester where we talked about a lot of weather topics, anywhere from lake effect snow to even space weather, which was my favorite show of the semester.
Yes.
Because space is cool.
Yeah, who knew you could have weather in space, right?
Apparently somebody at NASA did, because that's where we got a lot of our information from. They were very useful.
Yes, it
NASA.
was.
Great American resource.
So let's get to our segment, #AskAMet, where we answer your Twitter questions.
We're doing things a little different this week, though. Christine and I are going to be the ones tackling your Twitter questions. Christine, I think you took on the first one this week.
Yes, I did, Liam. Our first question comes from Gary in Oswego. He wanted to know what the difference is between El Nino and La Nina. So let's first define what they are. So El Nino and La Nina are both complex weather patterns that result from fluctuations in temperature between the ocean and the atmosphere above it, in specifically the equatorial Pacific Ocean. El Nino and La Nina are opposite phases in what is known as the El Nino Southern Oscillation, or ENSO cycle. Now I know that's a lot. It's a mouthful, but let's break it down. So in normal conditions, trade winds that blow east to west across the equatorial Pacific blow warmer ocean waters towards the western Pacific near Asia. But every 2 to 7 years, the trade winds weaken, causing the warmer waters to move eastward. And this cycle of warmer than average temperatures is called El Nino. Now, impacts of El Nino are typically felt during the wintertime in North America, as these warmer waters cause the jet stream to intensify and shift southward, causing wetter than average conditions in the southern U.S. and then drier conditions over the northern U.S. and Canada. Then eventually, the trade winds pick right back up again, sometimes even stronger than before, pushing warmer waters westward, with colder waters taking its place in the eastern Pacific. Now, this cycle is known as La Nina. These colder than average ocean temperatures cause the jet stream to shift northward, causing drought-like conditions in the southern U.S. and cold, wet conditions for the Pacific Northwest. Now, as I mentioned before, each cycle occurs every 2 to 7 years, with El Nino occurring more often than La Nina, and both cycles lasting around 9 to 12 months or more at a time, so they're both pretty long cycles when they're occurring. Now, these temperature variations have large-scale impacts not just on our weather here in the United States, but on global weather and climate across the globe and last for an extended period of time. And a fun fact, I know Liam loves fun facts, we are actually currently not in either one of those phases right now. We're actually called in what's just known as neutral conditions.
You know, another fun fact, Christine, I actually wrote a paper about El Nino conditions in freshman year.
Wow.
It was about how El Ninos affect nor'easters, which is actually our WeatherWise topic of the week this week. We're talking about nor'easters, so we'll have that coming up in a little bit. And our next Twitter question comes from Bobby in New Jersey. He asked, what's the difference between sleet and hail? Now, we already talked a little bit about sleet before, remember, from one of our earlier shows. Let's talk about hail. Hail forms are then strong thunderstorms during the warm season inside the clouds. And again, sleet, as you remember, forms during the cold season as it falls from the clouds, again, like most precipitation tends to. The main difference is that sleet typically starts as snow. The snow falling passes through a warm layer in the atmosphere as it falls. The snow is going to melt. Sleet will then form as this melted snowflake passes through another cold layer of the atmosphere and refreezes into small ice pellets. In order to get the hail, though, you need a very strong updraft in a thunderstorm. You only get a strong updraft if you have a large amount of instability as a result of warm air found in the summertime rising in an environment that's relatively cooler than the parcel of air that is rising. Now, once this warm air rises, it begins to cool and condenses to form the clouds, and that eventually helps our thunderstorm to form. Now, within this thunderstorm this thunderstorm, there's the updraft. If it is strong enough, the water vapor in the cloud will rise up and down within the cloud, becoming super cold and attracting more and more moisture that freezes and gets bigger and bigger. Now that is what forms our hailstone. And generally, these strong updrafts are only found in what is known as a supercell thunderstorm, one that generally exhibits rotation, is how we define that here in the meteorological community, at least.
Yes, and I get a lot, people say, oh, well, it's hailing outside, but it's actually sleet, and a lot of people don't really know that.
Yeah, so generally, if it's winter, it's usually pretty safe to assume it's sleet. If it's the middle of summer, you're not going to be seeing sleet, which is generally considered to be a more wintry precipitation.
Mm-hmm. Yeah. Now, coming up after the break, Liam is going to break down this week's weather highlights.
We'll be right back. Don't pick up that remote.
Welcome back. It's now time for weather highlights with meteorologist Liam Healy. So Liam, what's going on in the world today?
Not doing the world today. We're just sticking right here in the national view. We're looking at current temperatures right now. We're going to take a look at what's going to be happening over the next couple days across the United States. Right now, you can see pretty much most of the area is sticking around in the 30s. You can see a lot of cold air intruding into the entire United States, all the way from Maine right over to Washington and Oregon. We're going to put these temperatures into motion across the next couple days. You really start to see, this is Thursday morning across the entire United States. You can see a majority of the entire United States is sitting in this blue shade, which indicates temperatures of 50 degrees or below. Now, a lot of these places, especially down south, this is definitely a lot cooler than average than we should be seeing for this time of year. Now, this is really not really too unusual. You just see a lot of these cold intrusions. We did have that big cold front come through associated with our nor'easter that just dropped a lot of snow across the entire area. That is definitely the cause of why we're starting to see these colder temperatures. And we also have a large low pressure system working in off the coast of California that's going to help to drag in some of that cold air down from the mountains and through the entire Rocky Mountain chain. Now, the rest of the week, we are seeing these temperatures do their normal daily fluctuations of warm to cold. We are seeing temperatures start to improve throughout Friday as we get towards the end of the week for the Gulf Coast and that area there. Really, though, that's associated with another rainmaker. So right now we are tracking some spotty showers right across the California, Los Angeles area. That is a storm that's going to track across the country. Right across here, we do see have a lot of spotty snow showers associated with some lake effect precipitation. That's occurring across the entire East Coast right now. But let's focus in on this storm. This is going to be another cross-country tracker, though it's not going to be as impactful as we saw with our past nor'easter. So this is just bringing spotty snow showers down to southern Utah, across the Rocky Mountains there, and even bringing some much-needed rain to Las Vegas, as well as the Arizona area. Phoenix had a stretch of almost 30 days where they didn't see rain, so all rain that they're getting right now is extremely beneficial and much welcomed. So we're going to time this out for you. We have our system here, and then we also have another system that's going to be bringing some snowfall over to the East Coast as we head through the rest of this week. So this is the Euro model. This is one of our global international models. We see the storm begin to move through and head towards the Denver area, producing another swath of heavy snowfall across that area. Just 2 weeks ago, they saw one of the most intense snowstorms they had seen for the month of November in almost 20 years. See, and we're also bringing more beneficial rain down to down there. We also see a cold front stretching across. That's going to be another cold air bringing into the area. Bringing this storm in, it's going to bring snowfall to the East Coast, and this is going to sit down off the Gulf. That's going to produce a lot of rainfall down from Florida and areas past, as well as a windstorm. That Clipper system is going to produce a lot of wind as we head through the rest of your week there for Halifax and Northeast. So as you head in, 7-day forecast courtesy of Storm Team 10. We see snowfall coming in for Thursday, Friday, just scattered snow showers across the Oswego area. Heading into next week, though, we do see the disruptive weather return, but we do get back into the 40s. We'll have the rest of weather-wise coming up in just a little bit. We're covering weather myths debunked. Welcome back to WeatherWise. It's time to break down our topic of the week. Today, we're talking about nor'easters.
Now, our topic this week has been quite the talk across the region as one just delivered 22.6 inches as the official total at the Albany International Airport.
Now, the highest snowfall report we could find was in Rensselaer County with 27.5 inches falling. Oh, wait. Yeah, so we are talking about nor'easters.
Yes, we are
Very
talking about
exciting.
nor'easters. All right, so yes, our weather topic of the week is nor'easters. So first, let's define what exactly a nor'easter is. So this is a storm that occurs along the east coast of North America and gets its name as it contains coastal winds typically out of the northeast. Now, these storms may occur during any time of the year, but are most frequent during September through April. They also typically bring precipitation in the form of heavy rain or snow, can produce gale force winds of speeds around 32 to 63 miles per hour, rough seas, and can cause major coastal flooding. The eastern coast of the United States is an ideal place for nor'easters to form, especially during the winter. This is because generally there is a strong temperature contrast between the cold land and the relatively warm ocean. The cold air is provided by the polar jet stream that dips down towards the south, allowing Arctic air to spill down in from Canada. Now, while the Gulf Stream, which we talked about during our Weather Drivers episode, supplies warm waters up the eastern coast. This large temperature contrast is what provides this baroclinic instability that gives these powerful storms the fuel and energy they need to thrive.
Now, there are different types of nor'easters that can be categorized based on the different way these storms develop. These are known as Miller Type A or Miller Type B storms. Now, Miller Type A storms, they originate in the Gulf of Mexico. They're going to stick along the coast and track of what we call a stationary front. Now, a stationary front is very basically just a front that doesn't really move. Now, you can see that evolution there. It comes up from the Gulf of Mexico where the warm waters and all that moisture helps to spawn a low pressure. Now, that tracks up the coast. It's forced up the coast because there's what we call a blocking high over the Atlantic Ocean. It's also known as a Bermuda high because generally it sits right over Bermuda. So it's kind of one of those neat little things we call here in meteorology. So that tracks up the coast, generally bringing snowfall to the coast as well as rain for the fishes out there. Nice little fish storm sometimes too. Now that really is dependent on where that snowfall is going to fall. We're going to talk about that in just a little bit when we come to forecasting the event. Now, a Type B storm is generally associated with a Clipper system. Now, these are going to transfer their energy offshore. You can see it right here. You have your Clipper system coming across the Great Lakes. It came down from Canada. It's going to transfer its energy right offshore and begin to move off the coast and into the same process. Again, a blocking high helps push it up the coast. And really, for them to be snow producers, a high pressure needs to be north of it to supply an ample amount of cold air. If not, generally, you're going to see a lot of rain. Now, the benchmark. This is one of our biggest things in meteorology. It's 40 degrees north and 70 degrees west. You can see right there in the graphic where the big X is. If a nor'easter tracks west of this, it generally means rain for the mid-Atlantic coast and into the New England coast. If you have a tracking to the east, you're going to see light snow on the coast and very little inland. If it tracks right over it, that's your big jackpot for the coast. You're going to see heavy coastal snow events with it tracking right over the benchmark. Now,
sorry, Liam. Some of these well-known nor'easters include the blizzard of '88. This is arguably one of the worst blizzards to occur in American history, as it killed more than 400 people and dumped as much as 55 inches of snow in some spots. And wind gusts at the time were recorded at 85 miles per hour in New York City, with heavy snow creating complete whiteout conditions in the city, if you can imagine that. Now, another very powerful storm was the March superstorm of 1993. This storm was remembered for the tremendous snowfall totals seen all the way from Alabama all the way into Maine. Now, high winds were felt all along the eastern coast. It caused extreme coastal flooding across the western coast of Florida and created unseasonably cold temperatures following right behind the storm. It's known to be one of the deadliest and most costly weather events of the 20th century. So Liam, these storms can be pretty powerful.
They are extremely powerful. My parents were actually caught in the Bronx of New York, one of the boroughs of New York City during the superstorm of 1993. I think that is, hearing that story so much growing up about how dangerous the storm was and how much snow fell, is why I'm a meteorologist today.
Now, coming up after our next break, we'll be talking about this week's weather myth. Can your tongue get stuck on a frozen metal pool? Stay tuned and find out. We'll be right back. Welcome back to WeatherWise for our segment, Weather Myths Debunked. This segment is where we take weather myths and prove them right or wrong. And for our last show this semester, Liam and I will be breaking down our weather myth today. Now tell us what we're talking about today, Liam.
Today we're really asking the question, will your tongue really stick to a frozen metal pole? I'm going to blow this up right now. The answer is yes, I did it as a kid. It hurt a lot. Much like this clip from one of my favorite Christmas movies. As we see him coming in here, we're coming in for the touchdown. He's going to be double dog dared. He's going to be triple dog dared to stick his tongue to the pole. And you can see right there, his tongue has gotten stuck to the pole. It's not coming out. It's not going anywhere. We're going to need to call the fire department for this one, guys. His tongue is just not coming off.
Now, Liam, I can't say I've ever done that, but as you saw in that clip, the answer is yes, you can get your tongue stuck. And why is that? Well, it starts at your tongue. Your tongue is covered in moisture, and this moisture can freeze with temperatures below 32 degrees Fahrenheit. Your body then counteracts the freezing by pumping warm blood to your tongue, which then warms up the saliva on your tongue through conduction. Sounds a little bit gross. But when your tongue touches the metal pole, all the moisture on your tongue is completely stripped of all its heat. The temperature then drops and the water freezes inside any pores and irregularities on the surface of your tongue. And this happens because the metal pole has a very high thermal conductivity, about 400 times higher than your tongue. And this is how it's able to transfer heat to itself a lot faster than your body can even replenish.
I can tell you the best way to do it is not to rip your tongue off of it, because that's what I did when I was a little kid. What I've learned now is you pour some warm water on the pole and your tongue will become unstuck. So,
wow, tip of the day.
I don't know anyone who's ever going to do this, but just in case, you never know.
Never know.
So coming up after the break, we're going to have our final weather checkup with meteorologist Christine Gregory. Stay tuned for more WeatherWise. Welcome back to WeatherWise. It's time for our local final checkup with Christine. Christine, what are we expecting the next couple days right here in Oswego?
Well, we're going to start things off with a winter weather advisory that's in effect for the counties of Jefferson, Lewis, and Oswego County. This is going to be in effect until 10 a.m. tomorrow, as we do have some very widespread scattered snow and some rain showers. Right now you can see a lot of the rain over the lake is occurring as rain and then transitioning to snow across parts of the Tug Hill, with some scattered snow showers across the Syracuse area as well as Fort Buffalo. Now we're going to expect to see these scattered showers continue into the rest of the couple of days. For right now, we'll talk about temperatures. We're actually above freezing, almost to 40 degrees here in Oswego, which is why a lot of the precipitation is falling as rain. So the roads are going to be a little bit slick and slippery outside. Now let's time out the snow showers that we're going to see tonight. You can see by 11 o'clock tonight, by Wednesday, a lot of these snow showers are scattered, and even a lake effect band tries to form just south of Oswego. Now I think this lake effect band has a great chance of reaching parts of southern Oswego County and into Wayne and northern Cuyahoga County. So definitely be on the lookout for that, as this lake effect band could reduce visibilities very greatly. And keep in mind that winter weather advisory that's in effect until tomorrow morning. So if you are doing any traveling tomorrow morning, definitely just make sure you're being aware of this lake effect band. And we could catch a break from the snow Thursday evening, but we start right back up again with another system moving in by Friday. And just to recap tonight, you can expect these snow showers with temperatures around 32 degrees. And with that, I'm going to toss it right back to you, Liam.
So that's all we have for tonight's episode of WeatherWise. We hope you enjoyed all the topics we discussed these past few months. We're really looking forward to seeing you again next semester. But first, Christine, what was your favorite thing we talked about this semester?
My favorite thing? Probably space weather, because I got to wear my shirt with all the stars on it, and no one really thinks of weather occurring in space.
My favorite thing was getting the tongue stuck to the pole, because it's one of my favorite stories from my childhood.
Yes, that was great. Now, thank you all for watching, and have a great rest of your evening, everyone. We'll see you next semester.